Our next speaker is Alan Jakimo, and if you've been here the last few days, you've known him well. Alan has a very interesting background. He went to law school at Harvard, studied under Lawrence Tribe, constitutional law, one of the greatest legal scholars of all time. Alan was a partner at Sidley Austin, the international law firm. He has served as an investment banker. He is a mathematician, a technologist, a bit of a transhumanist, understands singularity, and created his own special program. I would call it AI, but he might call it machine learning, called Kaboom. He has been the most trusted advisor over the years to both the Regenerative Medicine Foundation, Genetics Policy Institute, and also the Healthspan Action Coalition, which was just recently formed this year. And dear friend, Alan Jakimo.
Thank you, Bernie. Thank you for that very, very generous introduction. I think it may have been Richard Feynman who once said that anyone who tells you that, or maybe it was Einstein or Feynman, I'm forgetting which one, but anyone who tells you that they understand quantum mechanics really doesn't know anything about quantum mechanics. So that may apply to singularity as well. That was an attempt at humor. It may not have worked. Louder? Is this better? Okay. So this presentation makes much use of GPT-4, and so much use that it really needs to be regarded as a joint human-machine presentation. So I hope everywhere where I use GPT-4, I noted it, and forgive me if I made any errors there. So 3 parts, and I have what, 30 minutes? Okay, so 3 parts. The first is, as a general matter, what kind of policy-making questions are raised by artificial intelligence, particularly by increasingly powerful generative AI, and beyond that, artificial general intelligence, and ASI beyond that, which is artificial super intelligence. So that's part 1. As a general matter, what's the connection there? Part 2, as a specific matter, how does the general policy-making aspects of part 1 apply to Healthspan policymaking? And then the third part is, how can AI help us to understand, and there's a typo here. I put this together pretty quickly, so there's also probably many, many typos in this as well, for which I apologize. But that A in the whole should be before the word understand. So AI can help us, A, understand what is happening in the US Congress with respect to parts 1 and 2, and B, I think it can even help us draft what we may want to call the AI Regulatory Act of 2023, the AIR Act. So those are the 3 parts that we'll be looking at. So as a general matter, what policy-making questions are raised by artificial intelligence? We've got, like all great debates, we really need to understand what these words mean. So I asked GPT-4 to please tell me definitions of generative AI and AGI. And it's interesting to look at those 2 definitions. So first, as we walk through side by side, GAI is a subfield of artificial intelligence. AGI is a form of artificial intelligence. I don't know why there's that that distinction. Field form, do they mean the same thing? Second, GAI is characterized by algorithms that are generating information. Information in the form of data, information in the form of images like DALL-E 2, and I made use of DALL-E 2 as well, so you're going to see DALL-E 2 images as well. Text, audio, and it does this by learning and mimicking underlying patterns. Let's look at AGI, artificial general intelligence. We're not talking about generating data, we're talking about the possession of cognitive abilities to understand, to learn, to adapt. Really important to be able to adapt. And whereas GAI learns things and then mimics patterns it sees, AGI is a whole lot more like human intelligence. So two important distinctions. Much of what has been written by Ray Kurzweil in 2005, by David Webb, who was here a few days, up until yesterday, the concern was that if we get to AGI, then we get to ASI really quickly. We have the singularity, and much like the universe in which we find ourselves, much like it's very possible it began with a big bang and then a period of inflation afterwards, that analogy may hold true for artificial intelligence as well. If we get to AGI, then we'll have this singularity moment. There'll be a huge exponential growth in the power of machines, and Homo sapiens, watch out. That was the concern about AGI. But what we're seeing with GPT-4, and we'll go into this in greater depth, what we're seeing with GPT-4 is so much power and so much unexpected power from the people who created it that people like Max Tegmark, and we'll cover who Max Tegmark is as well, people like Max Tegmark and 31,000 other people who have signed the petition that has been put forth by his institute, the Future of Life Institute, that, hey, we need to pause. We need to pause and figure out what's going on. Because as Max covers in the first chapter of his book, Life 3.0, this needs to be figured out in advance. Because like the frog in the proverbial boiling pot of water, slowly the frog is killed. And like the astronaut being sucked into the event horizon around a black hole, once one toe gets close enough to be dragged in, or one strand of hair gets close enough to be dragged in, it's too late. So do we in fact need to figure this out right now? Do we need to pause? Do we need to hit the pause button on GAI so as to avoid the kind of truly dystopian society that we may not want to have? Why is this happening? Why has GPT-4 come upon us? What are the underlying factors? And I'm not going to go into all the detail, but if you read one of the leading textbooks called Deep Learning by Goodfellow, Bengio, and Corville, published by MIT Press in 2016, you'll see that there are three things that have happened. First, development of algorithms. For example, the deep learning kind of algorithm that allowed AlphaGo to beat the world's champion Go player. Go, by the way, for any of you who play that, know that Go is a whole lot different than chess. This isn't the deep blue system beating a chess player. This is deep learning's AlphaGo beating the world's Go player. So development of algorithms, really important. That tool that Evan was talking about at the end of his talk, that machine learning tool that Evan was talking about, Those algorithms have been developed over the last 10 years or so. A very important, the underlying mathematics there is a form of regression. We all probably know about linear regression. We've all probably had some exposure to linear regression. The kind of machine learning that Evan was talking about is based on logistic regression. So a whole lot of mathematics there. The second major factor, cloud-based affordable computing power. I'll never forget, I don't know, it was sometime maybe around 2004, and I was at the American Airlines terminal at Kennedy Airport, and I remember these huge advertisements, and I'm forgetting which company it was, but the question on that billboard was, are you ready for the cloud? So the availability of affordable cloud-based computing power is the second factor. And then finally, all of the large-scale data sets that have come into existence. PubMed, clinicaltrials.gov, NIH Reporter, the US Patent and Trademark Office. The US Patent and Trademark Office, by the way, last year adopted a much more powerful interface, but a lot harder to navigate. And then last, a system called Biomed LM. Does anyone know what that is? Well, it was originally called PubMed GPT, and it was a system developed at Stanford based on a GP2 model, and it was trained by the PubMed library. Each and every one of us can get the entire PubMed library. It's on a bigger data set called the pile. So Stanford went out with this system called PubMed GPT, and they got a letter from the US government. And the US government said, we're very sorry, but we have a trademark on PubMed, and your system is going to cause a lot of confusion. So Stanford had to change the name. So Biomed LM, trained on the PubMed library. So those are the three factors as to why we're here. So I often think that Bernie often refers to me as being an expert, but I really think that I'm a lot more like Forrest Gump. And just to illustrate my own Forrest Gump walk over the last half century. Back in the 1970s, I was learning how to program computers to become expert at playing tic-tac-toe. It was around 1973, 1974, I was studying the veena. The veena is a lot like the sitar, but it's played in southern India instead of northern India. And I was working with a professor who was putting together, a musicologist who was putting together a library of the music of southern India. And we decided that we'd write it in COBOL. COBOL is Common Business-Oriented Language. Back in the 1950s, if you were a computer programmer working for a business, you were probably programming in COBOL. So COBOL had a weakness. It was so structured, and by the way, this COBOL was generated by GPT-4. And I asked GPT-4 to write a COBOL program that would write other COBOL programs. So that's supposedly what this does. I don't have a COBOL compiler on my machine, so I can't test it. But the point is, it's very, very structured. And it's so structured that it wasn't able to adapt. Remember that key concept in AGI, adaptability. It wasn't able to adapt. So the idea that we had is, okay, when we hit those sorts of spots, we'll just use COBOL to do the adapting for us. COBOL will write COBOL programs. So that's back in the 1970s. Let's look at where we are today. I already mentioned AlphaGo, and what happens when AlphaGo plays AlphaGo? You get AlphaGo 2, which is even more powerful. So that was, I believe it was 2016, if I'm remembering correctly, that AlphaGo beat the world's champion. There's a wonderful account of this in a book written by a mathematician at Oxford, Marcus du Sautoy. Fantastic book. The title of the book is called The Creativity Code. I highly recommend it. I believe it may have been published 2 or 3 years ago. And then I asked GPT-4 not to to, I asked Dolly E2 to give me a graphic, showing GPT-5 writing GPT-6. Remember David Wood spoke about a concern, not a concern, but the potential for GPT-6 to be written by GPT-5. So I asked Dolly to give me that, and I couldn't make sense. I couldn't make sense of that graphic. You know, what is going on there? And I finally, I think, caught a glimpse. One of the key concepts in the transformer tool, remember GPT stands for Generative Pre-trained Transformer. The key algorithm is a transformer algorithm. And it's a little bit, for those of the mathematicians in the house, remember Markov chains. You have a string of objects that appear, and that, based on a whole lot of probability theory, that leads to the next element. Transformers are a little bit different than that. They have step A and they have step C, and there needs to be inserted something between them, which that diagram seems to be suggesting, but time just doesn't permit us to further explore that. So this is an example, and this is an example of GPT-4 writing Python code, and particularly Python code that uses vectorization. That machine learning tool that Evan was talking about, at its core is a concept called vectorization. I can turn a sentence into a vector, vector A. I can turn another sentence into vector B, and I can compute, remember from trigonometry, remember the concept of a cosine being the measure of the angle that two vectors make? I can do that with words. And the key function that allows you to do that is TF-IDF vectorizer. TF-IDF was the invention of a whole lot of people, but the person who's really credited with the point of singularity for TF-IDF was a mathematician and computer scientist trained at Harvard, and then he went off to Cornell. Gerard Salton. He was born in 1927 in Nuremberg, Germany. So that tells you that somehow his family escaped the Third Reich and got to the United States. He went to Brooklyn. I believe he went to high school in Brooklyn, then got his PhD studying under Howard Aiken, a giant in the field of computer science at Harvard. And then about sometime in the 1960s, he went to Cornell. So TF-IDF, total frequency, inverse document frequency. Time doesn't permit us, but you see it right there in the middle, TF-IDF. And TF-IDF creates these vectors for you. So for those of you who attended David Webb's talk, at the top of the slide where he was illustrating the 5 industrial revolutions, with the 5th industrial revolution coming about through NBIC, nanotech, biotech, infotech, cognotech, what Ray Kurzweil correlates to GNR, gene tech, genetic technology, nanotechnology, and robotic technology with strong AI. That 5th industrial revolution gets you to the concept of technological singularity. Lots of people cut off the word technological and it just becomes singularity. But also, as David Webb mentioned, the word singularity, he mentioned that it might go back to James Clerk Maxwell, who developed the electromagnetism laws. I think the concept of singularity may go all the way back to Epicurus in ancient Greece. I think if you read Lucretius on the nature of things, De Rerum Natura, if I'm remembering it correctly, you see aspects of singularity in the atomic theory that the Greeks had established and that got lost along the way and then rediscovered. So at some point, You have AGI developing in given fields, so there'll be an AGI for regenerative medicine. There'll be an AGI for how to get to Mars and beyond. Once you have a collection of these AGIs, once you hit a threshold, it becomes super intelligence rather than just general intelligence. So that's what's going on there. So 3 important works, 2 of which exist, one of which is to be published 2 years from now. The Singularity is Near, which Kurzweil wrote in 2005. The book that David Wood, I have a colleague named David Webb, so I'm constantly conflating those 2 names. So if I say David Webb, David Wood, please forgive me. And Aubrey knows this because he's corrected me on this, and I appreciate that. Kurzweil is scheduled to, his next book is supposed to drop in 2025, and you can see that it's already being advertised on Amazon. And interestingly, it's out of stock. It's never been in stock to be out of stock, but so be it. So Jean Loring, who I think has departed, Jean, I think, inspired all of us a few days ago with her haiku generated by GPT-4. So I asked GPT-4 to give me a haiku about the ever nearer singularity. And this is what, and this has GPT-4 and DALL-E too. So this is a graphic depicting the great Japanese poet Basho, if I'm pronouncing it correctly, who is known to as Basho is to poetry, Shakespeare is to plays, soliloquies, things of that sort. So tech singularity mirrors event horizon, mystery unfolds. There's a defect in that haiku. The first line is 6 syllables. So, that illustrates GPT-4 not being absolutely perfect because classic haiku is 575. Okay, so Jean inspired me to do this. Ask GPT-4 not to produce a haiku about that analogy that I was talking about between the singularity in the cosmos and the singularity in artificial intelligence. I asked GPT-4 to give me a Shakespeare-style soliloquy that makes this analogy that I was talking about. And here's what GPT-4 came back with. And I'm not a Shakespearean actor, but I'll give it a try. Upon the grandest stage, unknown, and darkness held prime spot, did suddenly a split in time burst forth with cosmic plot, from whence a tiny point emerged the grandest tale of life, a universe's infancy with energies so rife. From this, inflation's might did swell to stretch the cosmic form, thus stars and galaxies were shaped, complexities as norm. As time began to unfold and traverse through its frame, evolution birthed a spark, intelligent, aflame. In shadows whispered bright as day that sentient minds foresee, the dawn of new horizons cast by artificial seeds. Infinite potential springs, technology breaks through, and carbon biology welcomes silicon's charges and holds too. Artificial general minds, their faculties to range, all knowledge like the heavens vast, await for them to claim. Like cosmic shift they shall expand, their growth exponential. The singularity so near, its advent consequential. Again, that was generated by that prompt. So if that doesn't give you pause to say, hey, maybe Tegmark and his 31,000 colleagues who have signed that petition, Maybe this will give you pause. By the way, I did do some editing on this because there were some political aspects that I didn't want to sign up for, so I did do some editing to make it politically correct. All right. So that concept of the flame, this is probably one of my favorite songs. We Didn't Start the Fire, Billy Joel, 1989. So then I asked Dolly to give me a graphic. Give me a graphic of the Big Bang and the inflation following the Big Bang. And it gave me these, and to do it in the style of Da Vinci. So I didn't know which image to pick, so I picked all four, and I'll let you all be the judge. On the left is the cosmic singularity with that astronaut getting sucked in. It's usually, if you read general relativity, it's usually Alice and Bob, A and B, getting sucked into a black hole. On your right is the technological singularity, and notice how a whole cityscape has already crossed through the event horizon and is inside the event horizon. So this is what made Max Tegmark famous. And what you're looking at is a map of the cosmic microwave background. Back in the 1990s, Max and a colleague did the software that did the signal processing to generate this map. This is a picture of the universe that we live in 380,000 years after the Big Bang. The same type of signal processing software that Max and his colleague used in the 1990s to generate that was and is being used by at least one of the high throughput genome sequencing companies, because as a mathematics problem, the signal processing that's needed to produce this is the same kind of signal processing technology that you need for signals coming from a high throughput genomic sequencing system. So that's the same Max Tegmark whose institute, I shouldn't call it his institute, he directs it, but it's the same Tegmark, the same Future of Life Institute that has proposed the moratorium. These are illustrations of his books. On the left, Our Mathematical Universe. There's a cosmologist and string theorist, in fact, regarded as the parent of string theory, Leonard Susskind at Stanford, and Max goes off from Susskind's view. Everything around us may just be the projection of a hologram sitting on the surface of the event horizon around the black hole that we're nearest. And then, and that was 2014. In 2017, Max wrote this book, Life 3.0. The first chapter of this book, and Bernie and I have discussed that chapter. The first chapter of this book out Asimov's Asimov. The subtitle is Being Human in the Age of Artificial Intelligence. So this is the moratorium. How am I doing on time, by the way? Okay. So this March 22nd, 2023, this dropped on the Future of Life website. This is regarded as, it's called the open letter, and I'm forgetting the rest of the title. But in it, those who have signed this letter, and it's a letter, not a petition. This letter, we call on all artificial intelligence labs to immediately pause for at least, and that at least is really important, because my own view is that what they're calling for is going to take a whole lot more than 6 months. But we'll put that to the side, and they acknowledge that by saying at least 6 months. to pause for at least 6 months the training, and this is really important to focus on, the training of AI systems more powerful than GPT-4. This pause needs to be public and verifiable, and as David Wood told us a few days ago, it needs to be international in scope. It needs to include all key actors. And if the pause can't be done quickly, then governments should step in and institute this moratorium. Of course, once you do that, what policies should government be following? And we'll get to that in part 3, because we're in the process of developing a machine learning tool answer to that question. Just like Aubrey's trainees are using AI to attack the problem that Evan was talking about, the networking, machine learning can also be used for policy making. And what's really important is we're not, this open letter is not saying stop all development. That's not what it's saying. It's saying stop training anything that's more powerful than GPT-4, but still go, keep doing all of the development that you had been doing up to this point. So that open letter was published in March 2023. A few weeks ago, Sam Altman, the founder of OpenAI, made the headlines around the world, and here's the Daily Mail from across the Atlantic. Here's the Daily Mail quoting Altman, and Altman admits to Congress that, yeah, things could go vastly wrong here. Things could be vastly wrong, but it's more of a Gutenberg printing press moment than an atomic bomb moment. Why did Altman specifically make that reference? Because at the end of April, this congressional bill called the Block Nuclear Launch by Autonomous Artificial Intelligence Act of 2023 was introduced into the House. So you've got senators and congressional representatives, at least one of whom picked up on this moratorium, and this is the kind of legislation that's following. And there are 12 other bills that this comes up in. Timing, how much? I'll get to the punchline. Read through the moratorium, you'll see that it covers, why now, what needs to be done technologically now, and what needs to be done policy making now. No have time to go through the details, but that's all there in the moratorium. And what's interesting is to map these principles into the principles that David Wood has published and has spoken to us about earlier this week. And those are, I stole this slide from David's presentation. I hope he doesn't mind. I don't think he will. These are the principles that he writes about in the Singularity Principles. And note the subtitle, Anticipating and Managing Cataclysmically Disruptive Technologies. All right, so I'm going to go to part 2 really quickly. So as a specific matter, how does this policy-making stuff relate to Healthspan matters? So I came up with the Aristotelian syllogism on the right. AI applies to healthcare. I took judicial notice of that. Healthspan is a field in healthcare, judicial notice. AI applies to the field of healthspan. And for that, I'm going to show you PubMed real quickly. The graphic on the left is Aristotle discussing this with his students as depicted by Dolly 2. All right, so if you plug into PubMed a search which is designed to bring to you the intersection of AI and Healthspan, 42 hits, and you can see that I tried to narrow this just to articles that mention this in their title or abstract, so that I could narrow it really quickly. And an example of one of those 42 results, the title, Artificial Intelligence-Based Approaches to Identify Molecular Determinants of Exceptional Health and Lifespan, an interdisciplinary workshop at the National Institute of Aging, held in 2019, published in Frontiers of Artificial Intelligence. So clearly the answer is, of course, AI. Of course AI applies to the field of Healthspan. Evan just showed us in that machine learning tool. He just showed us that. So of course the answer is yes. So part 3, how do we, just like Evan and Aubrey and their colleagues are using AI to help pursue that networking theory that Evan was talking about, we can use AI to help us sort through these documents and to help us draft the AIR Act of 2023. So I'm going to, I want to be quick. So up until 2 days ago, there were 60 such bills and resolutions introduced. This week, 2 more were added to the pile. And what we've done is we've done an initial cluster analysis. We've done an initial cluster analysis on this, and where is that? I'll quickly. So remember Evan used that word cluster? What we're doing here is, and by the way, we did this on the raw data. We made no attempt to clean up the data whatsoever. And there are at least 7,049 sentence-like structures, because this particular instance focuses on sentences. So there are 7,040 sentences. And I asked for, and this is one of the parameters you can control, I asked for 25 clusters. And remember, Evan was talking about the features matrix. Remember, he had that in his slides. This features matrix has more than just the 3 or 4 features that Evan, I think, was showing us. And notice some key words there. And by the way, the words look strange. The words look strange to you because they've gone through a process called stemming. In order to vectorize sentences with TF-IDF and then do all sorts of neat correlations and whatnot, clustering analysis, you want to have the roots of words. That's called stemming. So that's why these words look a little strange to you. But look at some of the red words. Ethnic, equita for distributive justice, environment, ethnic minor group. There's nuclear in cluster 4, peace building in cluster 6, cluster 7, unmanned aircraft legislation. Health, where am I looking? Yeah, I'm sorry, cluster 13, health, maternal care, mental health, outcomes, individuals. So all of the sentences in that cluster fit that description. So in the interest of time, you can also get TF-IDF weights for each word. You can see that health is way, and I cut out a lot of the words that are gibberish that have to do with the art of legislation. So these words are a subset that are meant to be substantive. Look at how high up health is. Look at how high up health is. That tells us that this body of 60 bills, now 62 bills, have a whole lot of stuff in them about health. One of them, and I may have inadvertently cut it out of the presentation, one of them talks about quality of life in the Medicare setting. So that's going to be all about Healthspan. So here's where we are. We've done that. We've done that initial. We've done the initial process. Next steps are to clean up the input, rerun the cluster analysis, analyze the 29 or 30 that pertain to health, consolidate David's 21 principles with the principles in the moratorium, build a machine learning model that allows us to apply those principles to each piece of legislation with the idea of being able to generate at least an initial draft of a consolidation of the best. You know, we're seeking the best and the most thoughtful to result in the AI Regulation Act of 2023, the AIR Act. And that's all GPT-4 wrote, folks.
Thank you. Oh my gosh. So you gave an incredible presentation. Thank you for clearing it all up for us. Some of those slides were a little technical, but I will say this. Some of us will just remember the one word in all the things you said, and it was cataclysmic. Cataclysmic. And when leading scientists say, put a hold on something 6 months, all right? Wait a minute. What if they don't put a hold on it 6 months? I submit to you, they aren't going to put a hold on it 6 months. So is this like dogs and cats living together, like in the movie Ghostbusters? Is something, life as we know it is going to explode? Alan, what does it all mean?
Yeah, so to that question, Sam Altman is, I think his official title is CEO. I think he's the CEO of OpenAI. And, look at what he said. Or what at least he was reported to have said. I should be it's what he was reported to what he said. It could cause, he admitted under questioning and under oath, it could cause significant harm to the world. He obviously was briefed before this about those bills that were started to be introduced in at least April, before he testified about the nuclear aspect of this. So he was careful to say, hey, this is a Gutenberg moment, and whatever cataclysms followed from that, but not an atomic bomb moment. So that's how Sam answers it. Other information technology company executives have been quoted as saying, hey folks, it's not a mystery. It's not a mystery, it's not dire. You know what, I skipped over an important prompt that I did. So I also, just to make sure I was balanced, because you've got to be balanced in this, just to be balanced, I asked for a 10-sentence essay that argues against a moratorium on training GPT models. And, and here's the conclusion. Concerns are valid, but a moratorium may come at the expense of scientific progress and other potential benefits. A more comprehensive approach than the approach that's posed in the moratorium is policy formulation, governance, transparency, and international cooperation. So,
well, sure, it'll say that. Self-preservation. And this is why it's important that all of this be under adult supervision. Absolutely. Alan, thank you.